10-minute summary for investigation 3C. So there are 3 points, key points in this investigation. So key point 1, let's go one by one. If the point satisfies the equation, then the point is on line. Okay, so we have this equation. Let's take this equation as an example, and let's see if some random points are on this line. So let's take something like maybe 5, 3. And let's check to see if this point 5, 3 is on the line of that equation. So in this case, we have x equals 5, y equals 3. And 3 plus 3 is 6. 2 times 5 minus 4 is 1, and 2 times 1 is not 6. Therefore, this 5.3 failed the test. That means it's not on the line. How about, let's take another point. How about for negative 3? Let's take the same equation as a point tester. Oops. Sorry about that. And let's plug in numbers. X is 4 in this case, y is negative 3. Negative 3 plus 3 is 0, and 4 minus 4 is 0, so this is true, so it passed the test. Therefore, 4, negative 3 is on the line of the equation y plus 3 equals 2 times parentheses x minus 4. How about the next equation? How about the next key points? I'm sorry. Graphing by plotting. So how do we actually graph this equation? Well, we know that if we know 2 points, if we can find out the 2 coordinates, then we can plot the points, and then we can connect the lines and draw a line, and that's how we graph the linear equation. So let's find 2 points using this equation. Okay, let's say x equals 0. That's an easy point. So x equals 0. Therefore, this is negative 4, and 2 times negative 4 is negative 8. And then subtract 3 from both sides. And the right side will be negative 11, and the left side is 0. So first point is 0, negative 11. See, by plotting some numbers for x, then we can solve it for y, and then all we have to do is solve it for y, and we find another point. So let's find another point. Let's say we have x equals 4. That's an easy point, because if you plug in 4 for x, this would be 0, right? And 2 times 0 is 0. And the same business, subtract 3 to cancel this out. But you got to do the same thing to the left side, so y will be negative 3. So the second point, it will be 4, negative 3. So we gotta plot the points. So let's have a coordinates. Oops. Let's have a coordinate again. Let's draw coordinates. Let's move it down over here. Let's plot the points. 0, negative 1 will be, this is 0, and equal 1, 2, 3, 4, 5, 6, 7. Let's say this is negative 11 right here. That's 0, negative 11. And then 4, 3, so you go 1, 2, 3, 4, and go down 3. So let's say this is 4, negative 3. And all I have to do is draw a line between these two and just simply extend it. And that's how you, it doesn't really look like it's hitting those 2 points, but you know what I'm talking about. So let's do it a little more better. It's good enough. You know what I'm talking about. Alright, the last key point is intersecting points satisfies both equations. So we have two graphs, a circle one and an oval one. And we have two equations, which is x squared plus y squared equals 25, and another one right here. Okay? So if you take any intersecting points, for example, right here, then this point is what? 3, 4? That should satisfy both equations. So let's try. So we have x squared plus y squared equals 25. And we want to test the point, which is 3, 4. So let's plug in the number. We have 3 squared plus 4 squared. 4 squared is 16, and 3 squared is 9. So this is true. How about the next equation? 16x plus 9 times y squared equals 288, and we plot the same points to see if it works. So we have 3 for x, we have 4 for y. And we know 4 squared is 16. That's 16. We know 16 times 3 is 9. Sorry, we have to use that. And 9 times 16 is 144. And 9 times 16 is 144. So that's true. You see, if the same will be true if you take this point right here as well, which is negative 3, 4. So the intersecting points must satisfy both equations, and that's how it works.